Let's talk about the most common faults on a permanent electric fence. So we're talking about a permanent high tensile electric fence and what kind of faults are going to cause you issues, which is going to help you find them when they occur, but also help you design your fence to prevent them in the first place. One of the most common things that people ask about in terms of load on a fence or a fault is the vegetation touching the fence. People are oftentimes asking, well, once my forage grows up, it's touching the wire, is that going to be a problem? Yes and no. So I don't think that the best solution for vegetation grounding your fence and creating a short is to mow it or manage that vegetation really. The best solution is to increase the size of your Energizer so that it's big enough to handle your typical fencing loads. So there's another video that we've created on testing and sizing your Energizer and your grounding system. If you've done what you can there and your fence is often running at a lower voltage due to vegetation, you need to get a bigger Energizer. You need more horsepower to enable the Energizer to put out enough flow to handle all those leaks and still keep adequate voltage on the fence. Now, even with an adequately sized Energizer, there's going to be challenging conditions like a really wet, rainy day. If you live in a very wet climate, you might want to create a way to disconnect low wires from the fence in times of wet snow or a lot of really wet vegetation on the fence. But a high enough powered Energizer can handle the vegetation load that's typical for your conditions. Most of the very common faults on permanent electric fences occur around the braces. At least that's a very common place for problems to occur. So in this case, you can see that we're missing an insulator on this hot wire right here, and that's allowing this hot wire to come into contact with this brace wire. And the brace wire then goes down to the bottom of the corner post, and it even touches the ground wire at the bottom on this fence, so that can create a dead short that's really going to take a lot of current out of your fence. You can also see, in this case, the wire is coming in contact with the brace wire, but it's able to move a little bit. And so sometimes if you're troubleshooting your fence, some of these shorts can be intermittent. For example, if your hot wire is coming in contact with a brace wire, or it's coming in contact with a piece of barbed wire or something like that, the wire can kind of blow in the wind, and you might see a big current going down your fence and the voltage drop, and then it kind of returns to normal on occasion, or it might only happen on a windy day. So look out for those kind of intermittent shorts when the wire is moving. In this case, we're going to replace this insulator. We can see that even with that insulator in place, this wire is still pretty close to this brace wire. This hot wire is too close to that brace wire. This is a really common problem on electric fences, the interplay between the brace wire and the hot wire. So I'm going to show you a couple tips on this brace of how to bring that brace wire away from the hot wire. In the past, I've tried to place plastic insulators in between positions where the wires come close. Sometimes online I've seen people putting insulated tubing over top of the hot wire, but by far my preferred method is to move the relationship between those wires so they're simply further apart. If you're using some sort of physical insulator to separate them, it's another chance for that insulator to pop off and fail at some point down the road. In this case, where my brace wire is in a figure 8 around the brace, I'm going to take a joint clamp and I'm going to install it around all 4 wires of this brace wire and tighten it down just a bit so that it's holding these wires together. Then we can slide that joint clamp up, and we showed this in the bracing video as well, tapping it up with a hammer if necessary, in order to move that brace wire further away from the hot wire. So that's already a lot better. That's pulled this hot wire quite a bit further from the brace wire. The way that we position our insulators and tie them onto the post also influences the spacing between the hot wires and the brace wire. So if you can see the way that we've tied these, we come so that the hot wire comes on the side of the post where the insulators are located and goes around the post from there. That allows you to shift these insulators toward the side where your insulators are, and then drive the staple that's holding this knot in place tight so that it prevents the insulator from rotating back around, and that will keep the hot wire further from the brace wire. Another common issue is having poor quality electrical connections on your fence. So every place where you have an electrical connection between wires, between fences, or for an undergate cable, in addition to twisting the wire onto the fence wire, your insulated wire onto the fence wire, you should also use some form of mechanical joint clamp. So if you only twist the wire on, not only can you have a lot of resistance in that connection, you can also have corrosion that increases the resistance, but it's also susceptible to just falling right off, and then you'll have no current on that part of the fence at all. So to decrease the resistance in that connection and make it permanent, we'll slide on something like this joint clamp and tighten it down. There's several forms of these joint clamps. I like these L-shape ones with the nut on them for most connections. Just tighten that down with a tool. That's not going anywhere. May sound obvious, but a pretty common cause of shorts is just simply leaving stuff leaned up against your fence. If you're out there working and the fence is off and you've got a rock bar that you leave sitting there, irrigation equipment like a hand line is obviously highly conductive and has a lot of surface on the ground for a short to go through, or wheel lines that roll into contact with your fence when it's windy, very common, or scraps of wire like a loop of barbed wire or high tensile that maybe you left out there when you were fencing and forgot to clean it up. And something like this may not be a problem that you'd notice for a while, especially if it's touching a wood post, and then all of a sudden you get a big rainstorm, everything's really wet and conductive, and then you might start to see some problems that you didn't have when it was dry. Of course, in a forested province like British Columbia, a common cause of fence faults will be trees or big branches falling across your fence. And something falling on the fence like this can push together hot wires and ground wires, which can create a dead short. The object itself can take current to the ground even if the wires aren't touching. And of course, if it hits the fence, it can break the insulators off of your wood post, your T-post, or your line post, whatever you're using. It can actually break those insulators right off. Now, the great thing about a high tensile steel fence is that when you remove the object from the fence, buck off that log or remove the branch, the wires can typically return to their former positions without too much damage. If you're using mild steel wire, mild steel will stretch, it will bend, and it's much more susceptible to damage than a 12.5 gauge high tensile steel that we recommend for these permanent electric fences. When something does impact your fence, whether it's a tree falling across it, a piece of machinery getting hooked on it, or wildlife or livestock going blasting through the wires, the likelihood that your insulators are going to break is going to have a lot to do with the quality of the insulators that you're using. So there's a wide range, like with anything, of quality, and you tend to get what you pay for. And I'm going to show you some of the differences and talk about it because sometimes the differences aren't that apparent just to your eye. If you were to walk into just any sort of farm store, you're going to probably find a lot of these different types of wood post or T-post insulators that are very cheap, and they are very cheaply made. So they're made with thinner plastic, but most importantly, what I want to point out is the UV stability of the different plastics that are used. And this is something that you won't notice on day one, but after this fence has been installed for 2-3 years, the cheaper quality insulators, the plastic will start to actually break down in the sun, and they'll become extremely brittle to where any little impact or even just the friction and pull of the wire can actually break them. And you can kind of see here a couple of poor quality wood post insulators and some of the damage and and UV damage they've sustained. If you contrast that with one of my favorites, a Gallagher wood post claw insulator, you can see they're just substantially thicker. There's a lot more plastic and they're UV stable. They come with a good warranty, which tells you that the insulator is going to last in the sun. And we'll have these in place for years and years and years, and they look exactly the same, they perform exactly the same, and the plastic doesn't really degrade. You know, you can contrast that with another small farm store insulator, and you can just see these smaller pieces of plastic, the smaller jaws are just more susceptible to damage from the wire, especially if this is used in any sort of change of direction location. Then there's a lot of tension on that insulator pushing back on it, and that'll just cut these insulators right in half. In locations where we have big changes going up or down, or there's a lot more pull on the insulator, I'll sometimes use these screw type insulators. And here's two versions, one from Gallagher and another one that doesn't have a brand on it. They look very similar, and they're similar in size, but if you look at the type of plastic they're made out of, this insulator here only has one type of plastic throughout, and it's been in use in the sun for a few years, and it's becoming very chalky and very brittle. And whereas these Gallagher insulators, this one's also been used in the sun for a while. It has a different type of plastic here in the middle that's really tough against the abrasion of the wire, and the plastics are UV stabilized. So I have these in service again for years, and you can see the difference in the quality of the plastic. When we look at our end strain insulators where we're tying off on our post, we can see similar differences here, both in the type of plastic and just the robustness and thickness of the product. And again, here we're comparing a Gallagher product called a end strain or high strain insulator. And it's made of plastic, but it's UV stable, and they're very tough and resistant to breaking against high strain or impacts to the fence. So what about other types of posts, like a Gallagher line post or a T-post? When something impacts your fence and the line clips or the insulators on those other posts break. So when the clips break on one of these line posts, then the wires can fall down out of position and they can come in contact with each other. And if you have ground wires and hot wires on your fence, then obviously that's going to cause a short. But if your fence is all hot or the wires don't actually come in contact with each other, the line post is an insulator itself. It's not conductive material, so you're not going to get a short from the wire touching the post. That's in contrast to any sort of steel post that you might be using in your line, such as a drill stem pipe or a T-post. If one of those insulators breaks or the wire falls out of the insulator, the hot wire in contact with the conductive post is going to be a big short because the steel post is conductive directly into the earth. Another common fault that can be difficult to find and diagnose are problems with your insulated lead-out cable or undergate cables. And the most common that we see is the use of household electrical wire for those purposes. But household electrical wire is only rated for 600 volts. So it's not about the size of the conductor. The size of the wire might be adequate to carry the current from your fence, but the insulation on the outside of the wire is insufficient. So especially when people run a hot and a ground both through on the black and the white wire, let's say, pretty soon that insulation jacket will break down. It won't happen immediately, but it will break down over time, and current will arc directly between those wires, causing a short. When you're using electric fence specific hookup wire, one that I've seen a couple times here is making a splice in that undergate cable somewhere or that lead out cable somewhere between two wires and then wrapping it in electrical tape. And electrical tape is also not a sufficient insulator for the high voltage of an electric fence. So then this is sitting down in the ground in the wet and the grass, and as soon as you have a rainfall or something like that, eventually current's going to arc through and create a big short right through that electrical tape. And furthermore, when I opened this one up, I saw that the wires were just twisted together, so it's not even clamped. It's a poor quality electrical connection that's going to have a lot of resistance, reduce the amount of current that can go through it, and the wire had been damaged when this splice was made, and so it actually just broke apart when I started handling it. So you want to use continuous runs for your undergate cable or your lead-out wire, and don't try to splice it in the middle of the run. Another fault you might find in your system is when wires get tangled together with one another. And this is especially common with offset fences where there's a high tensile electric wire on an existing barbed wire fence, for example, and the wire can wrap around the barbs and get caught. Or on a strictly high tensile fence where there's multiple wire tensioners, inline wire tensioners, in wind or when the fence wires are moving around, they can actually wrap around each other and get tangled. So one way you can minimize the risk of that is making sure that your offset hot wire is far enough away from the barbed wire fence. And when you have multiple inline wire strainers on different wires, don't put them all straight in a line, stagger them, space them out, sort of in a diagonal row a couple of feet apart, and that'll help minimize the risk they get tangled. In this case, this fault is on a bigger Energizer, so as we get closer to the fault, we can actually hear it snapping. And with our fault finder or a voltmeter, you can also check, and we can see there's voltage on this barbed wire fence now from being tangled up with the hot wire and the wires being in contact with each other. So that's another way when you're troubleshooting to track down if your problem is tangled up wires, check the voltage on the barbed wire. And because we have a remote on this fence, it's an I-Series, Gallagher I-Series Energizer that's remote capable, we can go ahead and turn this fence off right from here with our remote. Now it's safe and I can untangle that wire, and then I can just go ahead and turn that fence back on. And then we're back up to 10,000 volts. Hopefully this video will help you identify the most common causes of faults in a permanent fence and help you to locate them when they do occur and to prevent them in the first place. We also have a video on the most common faults in temporary fencing systems, and if you want to nail the brace building and keep that brace wire away from your hot wires, we've got a great video on that as well.